Hi friends, welcome back once again on my YouTube channel Gyan Guru by Gaurav Gupta. Now friends, as you all know that in these sessions we are discussing all the questions from the exemplar booklet of the NCERT class 11, right? Now in the previous video we have started with chapter 2, which is relations and functions, and we have discussed the first 15 questions which were short answer type. In this video, we'll be discussing the next 8 questions which are of long answer type. So if you look at the exercise from the exemplar booklet, you will find these questions. So let us discuss all these questions one by one in this video. Now the first question is already on your screen. Question number 16 is asking if G, a function like a relation is defined here, and they are asking is this relation a function or not. We'll have to justify it. If this is described by the relation gx is equal to alpha x plus beta, then we'll have to find out the values of alpha and beta, right? Now looking at this particular relation, we can see that for x equal to 1, 2, 3 and 4, we have different values. So at x equal to 1, the value is 1, at x equal to 2, the value is 2, right? So the first part of ordered pairs, whatever ordered pairs are there, the first part is different. So we can say that there is no value of x for which we have two images. There is no value of x which will give me two different values of y. So we can say that yes, this function is defined, or we can say that this is a function. Okay, so the answer for the first part will be yes. All right. Now the next task is they are saying that if this relation g of x is defined as alpha x plus beta, then we'll have to find out the values of alpha and beta. Okay. Now I'll look at the first ordered pair where the value of x is 1 and the value of function is also 1. So I'll calculate the value of g of 1 by substituting the value of x as 1 in the given relation. So it will give me alpha plus beta, which is equal to, I can say that the second part of the ordered pair, and it is also equal to 1, right? So alpha plus beta is equal to 1. This is the first equation. Then using the second ordered pair, I can put the value of x as 2, which will give me the value of the expression as 3. So it will be 2 alpha plus beta is equal to 3, right? This is the first equation. This is the second equation. You can simplify these equations and find the values of alpha and beta. So second equation minus the first equation. सेकेंड इक्वेशन में से फर्स्ट इक्वेशन को माइनस कर देते हैं. So 2 alpha minus alpha on the left hand side will be alpha, beta minus beta will be nothing, and 3 minus 1, that is 2. So we have got the value of alpha as 2. Alpha का value 2 आ गया. Now pick up this value of alpha and substitute in any of the above equations to obtain the value of beta. So मैं फर्स्ट इक्वेशन में अगर अल्फा का वैल्यू सब्स्टिट्यूट करता हूं, so it will give me 2 plus beta is equal to 1, and the value of beta comes out to be minus 1. So this is the value of beta, that is minus 1, and the value of alpha, that is 2. Now what you can do is just cross check if these values of alpha and beta satisfies the other ordered pairs or not. So looking at the third ordered pair where the value of x is 3, so I'll find g of 3. So g of 3 when substituted in, so I can define gx as alpha x plus beta. The value of alpha is 2, so 2x, and the value of beta is minus 1. So the function is defined as g of x is equal to 2x minus 1. Okay, so g of 3 will be 2 multiply 3 minus 1. So 2 into 3 is 6, minus 1 is 5. And you can see that the second part of this ordered pair is equal to 5. So yes, g of 3 is equal to 5. So does g of 4 will be equal to 7 if you will do the cross checking. Alright, so we can say that yes, these values of alpha and beta are correct. So alpha is equal to 2 and beta is equal to minus 1 is the answer for question number 16. Okay. Now let's move on and look at our next question, question number 17, in which we'll have to find the domain of each of the following functions. Now, for some of these questions, if you will check the answer keys that is given by NCERT, for some of them there is an error. So probably it will be a printing error from the side of NCERT. So I'll be giving you the correct answers. All right. So let's look at each of these 5 parts one by one, starting with part number 1. Now the function here is 1 upon under root of 1 upon under root of 1 minus cos x. All right. Now we have a square root sign. All right. And we also have a fraction in which there is a denominator. All right. Now, first of all, if we look at the square root is defined for any value which is not a negative number. So inside a square root, negative number nahi hona chahiye. All right. This is one thing. ओके सो आई कैन से दैट 1 माइनस cos x जो है ये या तो जीरो हो सकता है या फिर पॉजिटिव हो सकता है बट एट द सेम इंस्टेंस इट कैन नॉट बी जीरो एज वेल ओके जीरो भी नहीं हो सकता बिकॉज डिनोमिनेटर में जीरो अलाउड नहीं होता if the denominator is equal to zero then the expression will not be defined also simultaneously if you look at the range of cos x की रेंज देखोगे so cos x will be less than equal to 1 and greater than equal to minus 1 so the value of cos x lies between or lies starting from minus 1 up till plus 1 okay so cos x का वैल्यू अगर minus 1 और plus 1 के बीच में है so I can say that 1 minus cos x will always be a positive number or it can be 0 all right fine so 1 minus cos x will always be greater than or equal to 0 ये तो क्लियर हो गया सो अंडर रूट के अंदर greater than equal to 0 वैल्यू है but since the denominator cannot be equal to 0 so we can say that the value of cos x should not be equal to 1 okay now cos x 1 कब होता है when at what values of x cos x is equal to 1 so cos x is equal to 1 when x is equal to 2n pi. Alright, now since I know that cos x should not be equal to 1, so I can say that x should not be equal to 2n pi. Alright, so for all values of x which are real numbers except the values which are of the form 2n pi will be removed where n is an integer. All right, so the domain of this function will be x belongs to all real numbers except all the numbers which are of the form 2n pi where n is an integer. Why we have removed 2n pi? Because at x equal to any multiple of 2 pi like 0 degrees, 360 degrees, 720 degrees and so on, the value of cos x will be equal to 1. Okay, if the value of cos x is equal to 1, then 1 minus cos x will become 0 and the denominator of this function will become 0 and this function will not be defined. Alright, so 1 upon 0 form is not defined. That is why we have removed all the values of x which are of the form 2n pi. Alright, so that is the first one. Now let's move on and look at the second part of this question. Now second part, it is 1 upon under root of x plus modulus x. Alright. Now once again, the denominator should not be equal to 0. Right. Now here x can take different values starting from some negative values. It can be 0. It can be positive values. So since we are using a modulus function, so I'll divide the entire number line, all the values of x in 3 parts. When x is negative, when x is 0 and when x is positive. Okay, so let's take any random value of x which is a negative number. So let's say at x equal to minus 3, what will happen to the denominator? The denominator is under root of x plus modulus x. Now x is minus 3 plus modulus of minus 3 will be 3 and this will be equal to 0. But the denominator should not be equal to 0. And you can observe that the denominator will become 0 for every negative value of x. So it is clear that x cannot be a negative number. right? This is number one. X cannot be negative. Now let's check for x equal to 0. Now when x is equal to 0, the denominator, which is under root of x plus modulus x, will be equal to 0. So it is again clear that x cannot be equal to 0. Now for any positive value of x, the denominator will always remain a positive number. Inside the square root, you will have x plus modulus x. If x is positive, then x plus modulus x will also be positive, and hence this function will be defined. Okay, so we can say that the domain of this function will be all positive real numbers. Okay, so x belongs to all positive real numbers will be the correct value of the domain of this function. All right, fine. Now let's move ahead and look at the next question. Now the next part is fx is equal to x modulus x. Now x modulus x, it does not have any restriction. It does not have a denominator. It does not have anything which is in the square root sign. So if x is negative, let's say x is minus 3. So this function will become minus 3 multiplied by 3, that is minus 9. No problem with this value, right? So we can say that this function will be defined when x is negative, right? Now when x is 0, अगर x का value 0 है तो function का value 0 हो जाएगा. Again it is defined, no problem at all. Also if x is positive, let's say the value of x is 3, so the function will become 3 multiplied 3, that is 9, which is also a defined value. Okay, so I can see that this function is defined for all the negative values of x when x is 0, also for all the positive values of x, right? So this function is defined when x is any real number, be it positive, be it 0, or be it negative. No problem with this. Okay, so that was part number 3. Moving on to part number 4. Part number 4 is easy. It has a denominator, right? So x cube minus x plus 3 divided by x square minus 1. Okay, so we can say that this is a rational function and it will be defined if denominator is not equal to 0. Okay, so that means x square minus 1 should not be equal to 0. So that means x square should not be equal to 1, and hence x should not be equal to minus 1 or plus 1, right? So this function will be defined for all real numbers except two numbers, minus 1 and 1. Okay, so minus 1 and 1, these two elements will be removed from all the real numbers, and that will become the domain of part number 4. Simple. Now last part, it will be on the similar lines as we have done part number 4. This one is easier. So denominator, just pick up the denominator here. 2x minus 8 should not be equal to 0. So that means x should not be equal to 4. So the domain of this function will be all real numbers except 4. So only this element 4 will be removed from all real numbers and this function will be defined. Alright, so this is the domain of this function. Right? So that was question number 17 from long answer type questions. Let's look at the next question, question number 18, where we'll have to find out the range of the following functions. Now, looking at the first part, now its answer is given wrong in the answer key of Exemplar booklet. So let's have a look at this function in detail. So function is f of x is equal to 3 upon 2 minus x square. Okay. Now, first of all, we know that if denominator is equal to 0, then the function will not be defined. Okay. So that means if x is equal to under root 2, if x is equal to under root 2, then the function will not be defined. But हमें डोमेन कैलकुलेट नहीं करना, हमें रेंज कैलकुलेट करनी है. ठीक है. So x equal to under root 2 के लिए वैल्यू और डिनोमिनेटर 0 हो जाएगा. Okay. But what if the value of x is more than root 2 or less than root 2 or it goes towards negative values? Okay, so we will check it out, right? So at x equal to under root 2, this function will not be defined. Also at x equal to minus under root 2, this function will not be defined because the denominator will become 0. Now let's check the value of the function for other values of x, right? Okay. Now I'll consider only the positive values of x in the range 0 to under root 2, or negative values of x which are in the range of minus root 2 up till 0. Okay, so that means I'm looking at all the values of x, such that they are starting from minus root 2 up till root 2 but not included. So x belongs to minus root 2 up till root 2. Why I'm taking this range? Because here the denominator will be positive. Denominator positive hoga, right? Okay, now if the denominator is positive, I can say that the value of the entire function will be positive. Okay, if the denominator is positive, then the value of the entire function will be positive. Okay, so the minimum value here will be 3 upon 2 when x is equal to 0. अगर मैं x को 0 put कर देता हूँ, so minimum value of the function will be 3 upon 2. Okay, when x is positive. Now the maximum value of the function. So x को अगर मैं let's say 0.1 put करता हूँ. If x is 0.1, then x square will be 0.01. So 2 minus 0.01, the value in the denominator will start diminishing. So denominator का value कम होता रहेगा and the value of the entire fraction will keep on increasing. So जैसे जैसे denominator का value छोटा होता रहेगा, the value of this entire expression will keep on increasing, right? Okay, so if I'll keep on increasing the value of x up till root 2, okay, so the value in the denominator will go near to 0, 0 के पास जाती रहेगी, and hence the value of this expression will keep on increasing and it can go up till infinity, right? Now this is when x belongs to this range minus root 2 up till root 2. Now if x is increased further above root 2 or x is decreased further below root 2, that means if x belongs to the range minus infinity up till minus root 2 or root 2 up till infinity, then what will happen? If x is in this range, then the denominator will become negative, right? Denominator negative बन जाएगा and the magnitude can be taken up to any value, right? So in this case, the value of the expression will be minus infinity up till 0, and it can take any values below or like from minus infinity up till 0 but not including 0, right? So this will be the entire range of this function. In the booklet, you will see that the range is only 3 by 2 up till infinity, but this function can also become negative. Let's say put x equal to 4. अगर x का value 4 है, तो denominator क्या हो जाएगा? It will become 3 upon 2 minus 16, that is 3 upon minus 14, and it's a negative number, right? So if you'll keep on increasing the value of x, right, above root 2, then the value will be negative and it can take any negative value. All right. So the range will be minus infinity to 0, union 3 by 2 up till infinity, where 3 by 2 will be included. The value 3 by 2 can be obtained at x equal to 0. Okay, so this will be the entire range of the first question. Okay, now moving on to the second part. Now second part is easy. So function is 1 minus modulus of x minus 2. Okay, now look at this part of the question, modulus of x minus 2. I can say that the value of modulus of x minus 2 can never be negative because it's a modulus function. Modulus function है तो value कभी भी negative नहीं होगी. Okay, so I can say that its minimum value can be 0 and maximum value it can go up till infinity, right? अब 1 में से 0 माइनस होगा तो वैल्यू 1 आएगी, 1 में से 0 से बड़ा माइनस होगा तो 1 से वैल्यू कम होती रहेगी. So as the value of modulus of x minus 2 will increase, the value of this entire expression will decrease. Okay, and it can be taken up till minus infinity. Okay, so जैसे जैसे मॉडुलस ऑफ x minus 2 इंक्रीज होता रहेगा, 1 minus this value will keep on decreasing. All right, so it can go up till minus infinity, right? Okay, and this value of modulus of x minus 2 can be 0 as well. So 1 minus 0 is 1. So this will be the range of this function, minus infinity से 1 तक, 1 will be included. Okay, moving on to the part number 3, fx is equal to modulus of x minus 3. Now this is any other modulus function, any random modulus function which can never be negative. Okay, so I can say that the range will be starting from 0 up till infinity, where 0 is included, right? Now how can I make this function equal to 0? The value equal to 0 कैसे होगी? X का value 3 put कर दो. So if x is equal to 3, then the function will become 0. For no value of x, this will be negative because this is a modulus function once again. So the range will be starting from 0 up till infinity with 0 included. Now the last part, part number 4, is f of x is equal to 1 plus 3 cos 2x. Okay. Now once again we will look at the right hand side one by one. We'll divide it in different parts. So first of all, look at this function. The hint is also given. So cos of 2x is less than equal to 1 and greater than equal to minus 1. Okay, so 3 cos 2x का value क्या होगा? 3 cos 2x will be less than equal to 3 and greater than equal to minus 3. क्या किया? 3 से multiply कर दिया. Alright, then let's add 1. So 1 plus 3 cos 2x. So let's add 1 will be between minus 2 and 4. All right, so the range of this function will be minus 2 comma 4 and both included. That one was very simple, provided you know the range of cos function. Okay, so friends, that was question number 18. Let's move on and look at the next question, where we'll have to redefine a modulus function. Now, modulus function, you must know that it changes its sign. It changes its sign along a particular point. So I'll give you an example. Let's say there is a function f of x is equal to modulus of x minus 1. Okay. Now, modulus of x minus 1 will change its sign along the point x equal to 1. अब ये x equal to 1 कैसे आया? मॉडुलस के अंदर क्या है? एक्सप्रेशन क्या है? x minus 1. इसको 0 पुट कर दो. So from here you will get x equal to 1. So if you plot the point 1 on the number line, so on the right hand side of this point, the value of the function will be x minus 1, and on the left hand side the value will be negative of x minus 1. So this function will change its sign along the point x equal to 1. Now the same principle will be applied in this question, but it will change its sign along two different points. Okay, so both the points are given. So I'll plot the number line. Now what is this? X minus 2. If I'll put it equal to 0, I'll get x equal to 2. So modulus of x minus 2 will change its sign along the point x equal to 2. So I'll mark x equal to 2 on the number line. So on the number line, on the right hand side of point 2, modulus of x minus 2 will be equal to x minus 2, right? Will be equal to positive of x minus 2. But on the left hand side of this point, the value of modulus of x minus 2 will be negative of x minus 2, right? Negative of x minus 2. So I'll write it here. So modulus of x minus 2 will be defined as x minus 2 when x is greater than equal to 2, and it will be defined as negative of x minus 2 when x is less than 2. Now similar will happen with the next function, with this function. This is 2 plus x. If I'll put it equal to 0, the value of x will be minus 2. So this function will change its sign along the point x minus 2. So if I define this function 2 plus x, this will be equal to 2 plus x only when x is greater than equal to minus 2. And this is equal to minus of 2 plus x when x is less than minus 2. Alright, so just taking into consideration about the definition of these functions, the number line is divided in three parts. Okay, this is part number 1, part number 2, and part number 3. So let's look at these three parts one by one. Okay, now part number 1. So I can say that this part number 1 is on the left hand side of both the points, left hand side of minus 2 as well as plus 2. So the function will be the negative of both these expressions because it is on the left hand side of both these points. So modulus of x minus 2 will be written as minus of x minus 2. Okay, and modulus of 2 plus x will be written as minus of 2 plus x. Okay, so this is region number 1. So if I simplify this, minus x plus 2 minus 2, so it will become minus 2x. Alright, this is how the function will be defined in region number 1. Now looking at region number 2. Now if the value of x is in region number 2, it is on the right hand side of point minus 2 and left hand side of plus 2. Okay, so the first function modulus of x minus 2, modulus of x minus 2 will still be negative. Okay, so it will be negative of x minus 2, but the second part will be positive. It will be positive of 2 plus x. Okay, so minus x plus x cancelled, 2 plus 2 is equal to 4. So f of x will be equal to 4 in this second region. Now finally the third region, in which if you carefully see, the third region is lying on the right hand side of both the points. So both the functions will be positive. So the first function will be x minus 2 and the second function will be 2 plus x. Alright, so that is equal to 2x. Fine. So this function fx will now be defined as, so it will be minus 2x when x is less than equal to minus 2. It will be equal to 4 when x is greater than equal to minus 2 and less than equal to 2. And it will be equal to 2x when x is greater than equal to 2. Okay, now at the points minus 2 and plus 2, you can take any of the definitions. So at minus 2 you can take this definition or you can take this definition. Both will give you the same answer. Also at x equal to plus 2, either you can use this definition or this definition. Again, both will give you the same values for the function. Okay, so this is how the function will be defined in question number 19. Okay, in the booklet there is a slight error while writing the answer. Never mind, you can look at this answer. I have given you a correct answer. Okay, moving ahead, question number 20. Function is defined, fx is equal to x minus 1 upon x plus 1, and then we'll have to prove something. So point number 1, we'll have to find out, we'll have to prove that f of 1 upon x is equal to minus fx. Okay, so f of 1 upon x calculate karte hain. So f of 1 upon x kya hoga? In the function, instead of x, substitute 1 upon x. So it will be 1 upon x minus 1 whole divided by 1 upon x plus 1. Alright. Now taking LCM in numerator and denominator, it will become 1 minus x divided by x whole divided by 1 plus x divided by x. Now x will be cancelled and you will get 1 minus x upon 1 plus x, which can be rewritten as, from the numerator agar negative sign common le lete hain, so minus of x minus 1 divided by x plus 1. I have written the denominator as it is. Okay. Now what is x minus 1 upon x plus 1? It is nothing but the function itself with negative sign retained. So minus sign retain कर लिया, and x minus 1 upon x plus 1 क्या है? It is just the function itself if you look at it. So it will be equal to minus of fx. Alright. So this is what we have to prove in part number 1. F of 1 upon x is equal to minus fx. Let's look at the second part. Okay, part number 2. I'll start from left hand side. F of minus 1 upon x. So instead of x, I will substitute minus 1 upon x. So in the function minus 1 upon x minus 1 whole divided by minus 1 upon x plus 1. Again, do the simplification the way we have done it in the first part. So minus x, sorry, it will be minus 1 minus x. All right, wait. So minus 1 minus x divided by x whole divided by minus 1 plus x divided by x. Now x will be cancelled from the denominator of numerator and the denominator of denominator. ये x cancel out हो जाएगा. So I'll have minus 1 minus x whole divided by minus 1 plus x. Okay, right? Now negative sign common ले लेते हैं from the numerator. So minus sign common लिया तो it will become x minus 1 and the denominator x minus, wait, x plus 1 हो जाएगा numerator and denominator will be x minus 1. Okay, now keep minus sign in the numerator and take x plus 1 from the numerator to the denominator and write it as x minus 1 divided by x plus 1. Right? Now what is in the denominator? In the denominator I have x minus 1 upon x plus 1, which is nothing but the function itself. So it will be minus 1 upon f of x. So minus 1 upon f of x. Yes, this is the same thing that we'll have to prove, and that's it. So this was question number 2 or part number 2 of question number 20. Okay. Moving ahead and looking at the next question, question number 21. Question number 21 is very simple. Now you are given two functions and you will have to find out the sum of these two functions, the difference, the product, and the quotient of these two functions. So I'll quickly write the answers. Now f of x is given and g of x is given. So f plus g of x can be written as f of x plus g of x. Now f of x is under root x and g of x is equal to x. Okay, so that is part number 1 over. Part number 2, f minus g of x will be equal to f of x minus g of x, and that is root x minus x. You can leave it here only. Now part number 3, f g of x. So that will be f of x multiplied by g of x. Okay, f of x is root x multiplied by x. So that is x raised to the power half multiplied by x raised to the power 1. When the bases are same and they are getting multiplied, the powers will be added. So it will be x raised to the power 1 upon 2 plus 1, and that is x raised to the power 3 by 2. So x raised to the power 3 by 2 is the answer. And finally, the fourth part, f upon g of x will be f of x upon g of x. So that is root x upon x. Now they are divided. So x raised to the power half upon x raised to the power 1. So the bases are same and they are getting divided. So power will be subtracted. So I take this power in the numerator only. So 1 by 2 minus 1, or x raised to the power 1 minus 1 by 2, which can be written as 1 upon x raised to the power half, which can further be written as x 1 upon root x. Okay. So power half is under root x and negative power hai to reciprocal ho jayega, and the final answer will be 1 upon under root x. Okay, so these were the 4 parts of question number 21. Looking at question number 22, and we'll have to find out the domain and range of the function f of x is equal to 1 upon under root of x minus 5. Now I have a square root function. So inside the square root, I cannot put a negative number. Also, it's a denominator, so denominator cannot be equal to 0. So simply I can say that x should be, or x minus 5 should be strictly greater than 0. It cannot be equal to 0 as well, right? So that means x is greater than 5. So x greater than 5, or I can say that x belongs to 5 comma infinity with open interval on 5. 5 is not included, will be the domain of this function. Alright. Now what about the range of this function? Now how to calculate the range? Now what can be the denominator? In the denominator x has to be greater than 5. Right? X का value 5 से बड़ा होना चाहिए. Done. So we can say that whenever x is greater than 5, okay, so the value in the denominator will be any positive number, okay. I cannot get a negative number in the denominator. Fine. So the range cannot be any negative real number. Also, this fraction cannot be equal to 0. 0 nahi bana sakte. So we can say that the range of this function will be all positive real numbers, right? Okay, so that was question number 22. Moving on to the last part, question number 23, the last long answer type question. So you are given that f of x is equal to y and y is equal to ax minus b upon cx minus a. I will have to prove that f of y is equal to x. Now, first of all, let us write f of y. How we can write f of y? We have f of x as ax minus b upon cx minus a. So, f of y will become, instead of x, just write y in the same function. So, it will be ay minus b upon cy minus a. Okay. Now, what is the value of y? Y is equal to this expression. So, in this function f of y, wherever y is, just substitute the value of y as ax minus b upon cx minus a. So, y ka value substitute kar do. So, a as it is, being very careful, ax minus b upon cx minus a, and then minus b as it is. Now look at the denominator, c as it is, and instead of y, I will substitute ax minus b upon cx minus a, and then minus a as it is in the denominator. Okay. Now you have this expression. Simplify this very carefully. Okay. So taking the LCM in the numerator, it will become cx minus a, and in the numerator it will be a square x minus ab minus bcx plus ab. Okay, then whole divided by, again taking LCM in the denominator, cx minus a. So the numerator of the denominator will become cax minus cb minus acx plus a square. Okay, which can be written as, so denominators of both numerators and denominators will be cancelled, like cx minus a will be cancelled. Okay, so it will be a square x minus ab minus bcx plus ab whole divided by cax minus cb minus acx plus a square. Now look at the numerators and the denominators separately. So in the numerator, AB and minus AB will get cancelled. Okay, and in the denominator, CAX and minus ACX will get cancelled. Right? So what will I have in the numerator is a square x minus BCX. Denominator is a square minus BC. Taking x common, So if I take x common, a square minus bc, and denominator is also a square minus bc, which will get cancelled, and I will get x. So I have proved that f of y, I started with f of y and I ended at x. So yes, f of y is equal to x. This is proven. Okay. So friends, that was 23rd question, the last question on long answer type questions. Now after that, we have some objective type questions which I'll be discussing in the next video. So stay tuned. We'll soon be uploading this video in which you will find all the solutions for objective type questions. All right. So friends, I hope you like the way we are solving these questions. In case you have any type of question, you want me to solve some particular thing for you, so you can leave your question in the comment section. I'll look at those comments and will probably make a separate video to basically like provide you the solution of the question that you are asking, or I'll give you an explanation for that. All right. You can share this video with your friends and family and subscribe the channel so that you will keep on receiving all the notifications of my upcoming sessions. All right. So friends, please keep watching these videos and keep learning through these videos. All the very best to all of you. Have a wonderful time. Bye bye.